Hello class, and today we are doing lesson 1.5, graphing ratio tables. So in our last lesson, we went over what ratio tables were and how they're basically sets of equivalent fractions, just not being simplified all the way to being simplified. So they're comparing pairs that are all equivalent. But why do we do that? Why don't we just keep it simplified? Let's see. So first I want you guys to copy this down into whatever sort of notebook you have. Here is a graph. There are two lines here. The green line, which is vertical, is called our y-axis. The blue line, which is horizontal, is called our x-axis. The point in which the two lines meet in the center, where it is perpendicular, right where they meet, right here, is called the origin, and we're going to talk about that later. And this makes up the coordinate plane. You'll be used to seeing this on graph paper or with lines here that are counting 1, 2, 3, 4, or however. But in the most basic form, this is the coordinate plane. Additionally, this is what's known as an ordered pair. An ordered pair is written with the coordinates x, comma, y. So that's telling us where we're going to put the point on our coordinate plane. And we'll get into it more. The way that I remember this one is it's in alphabetical order. It's in alphabetical order. So it goes x, comma, y. And before you ask, yes, there is a z, but we just don't deal with it. It makes it three-dimensional, and we just don't deal with it. So now what I want you guys to do is I want you guys to open your books to page 46. So we're going to be working really quickly on page 46. And on 46, we've got three problems. We've got problems 19, 20, and 21. So we're going to work together on these. So the two solutions that we have come up with were 5, 4 and 4, 5. So we're going to see what we think. Like I said, if you think that it is 5, 4, hit go slower. If you think that it is 4, 5, hit go faster. So we're at a close split. We're at about 2/3 say that it is 4, 5. And those 2/3 are correct. So our point is 4, 5. Like I said before, we go in alphabetical order. So when we're doing our ordered pairs, it's going to be x, comma, y. So we follow along this bottom axis. This is our x-axis. So I went over 4, and that's where my x value is. And then, time for my y value. I went up 5. So that's where my y value is. And by combining those points, I find my actual point right there. So Amelia asked, how do we look at a coordinate chart and find the 4, 5? How do we do that? So Vahe, how do you do it?
So as you can see on the right, you see that first it's an X, then it's a Y. So you see if you see the little dot kind of in the center, you see that it's connected to a 5 and a 4. So what's first? What's first? So first is the X, so that's the bottom. So it's 4 goes first because it's on the bottom, and then you can see Y's next. So look on the side and you'll see it's 5. That's connected to the dot.
Yeah.
Okay, so wherever the dot is connected.
So let's look at this next one here. So Havsep, what do you think this one is?
7/3.
It's 7, 3. So it's not in a fraction form, but yeah. So it's 7, 3 is what we say. It's an ordered pair. I see why you guys want to say 7/3, and it's kind of similar, but this is 7, 3. So let's look at this last one. I want to plot these points, and I'm going to plot 2 points, and you're going to tell me which point is correct, okay? So for my initial one, I'm going to plot right here, and I'm going to plot a point right here. So those are what I'm going to plot. Which one of these do we think is correct? Which one of these? The purple point or the orange point. And I'm graphing right now. I know it's a little confusing. And I'm graphing this one, 3, 2. So what do we think, Noah? What do you think? Which one's correct?
I think that the purple one is correct.
Yes, she is correct. So the purple point, we go over 1, 2, 3, and then on Y, 1, 2, and this is where they would collide. So that's where they would collide. Excellent. So based on such, for this other one, for the green point, am I gonna go to point number 1 or point number 2? Point number 1 or point number 2? Dolan, point 1 or point 2? So 1 or 2?
That would be point 2.
Yeah. So it's that point right there, point 2, because we go over 6 and then we go up 4. I find it easiest to do it in that order, to do it over and then up. Perfect. So what about this next point? This 8, 1. Is it going to be point 1 right there or point 2 here? So this is point 2, this is point 1. Is it going to be point 1 or 2, Michaela?
It's going to be point 1.
It's going to be point 1, exactly, because we go over 8, then up 1. And then lastly, Emma, what is our purple point going to be? Is our purple point going to be here? Or is it going to be here? Is it going to be this one, point 1 or point 2? Yes, as Ella says, it is point 1. So here's what we get. When I graph that, that's what I ended up getting. And so it's kind of cool. We see all of this. That's what I end up getting. So here's when we use our ratio tables to apply into our what we are learning. Similarly to our ratio tables. In fact, we did this ratio table pretty much yesterday. So let's look. The table shows the cost in dollars to create CDs of digital photos at the photo shop. The table also saw this information, or shows this information as ordered pairs. Number of CDs, comma, cost in dollars. It tells us our number of CDs is X and our cost is Y. And I'm even going to go over how we knew which one was which if it didn't tell us. How I knew which one was which if it didn't tell us. So, my first pair is 1 CD for $3. Who could tell me what the ordered pair for that would be? What would the ordered pair for that be? Havset.
1, 3.
Perfect. 1, 3. Hey, Noah, what is that second red part that I've got bleeped out was? This one right here. What number is going to go right there? So Noah says 2. Let's see. Whoop! She is correct. What about this next one, Giovanni? What's going to go in this red part right here? The one I just circled.
9.
Yeah, look at that. So all we did again was we just made equivalent ratios. So all I did was I made equivalent ratios. And as such, the next pair is 2, 6, 3, 9. And now we have to graph it. So it says this word here, start at the origin. The origin was that point where the x-axis and the y-axis meet, where it is exactly 0. So sometimes you'll see it, if it's just a positive graph, you'll see it right there. Other times you'll see it in the very center of the graph. So now we have to graph this problem. Here is my y values. Here are my x values. So the first one I'm going to put at 1, 3, which is right there. My next one I'm going to put at 2, 6, which is right there. My next one I'm going to put at 3, 9, which is right there. So when I undo my entire thing right here, I end up with this. Let's think about this pattern though, okay? The points appear in a line. So we see that if I drew a line right there, it would pretty nicely go through all of my points as I'm attempting to make it as nice as possible. But there, it pretty much nicely goes through all of my points. But I want you to tell me, what do you notice? Each point is what unit to the right? So How many units did each point go to the right? Anytime. I see people holding up their fingers. Yeah, hold up your fingers. How much did it go to the side every time? To the right. Careful, pay attention. It goes to the right 1 time every time. So this is a good idea. We're seeing this. It goes to the right 1 time. Because with this, every single time we go. Here it went from 1. So we went over 1. Then it went to 2. We went over another 1. Then it went to 3. So we went over another 1. So based on that information that we were just given, that it's 1 unit to the right, how many units up is it going to be on our fingers? How many units up? Yes, on our fingers it is 3. Because every time we go over 1 unit to the right, we go up 3 units. We go over 1, up 3, over 1, up 3. So it's kind of this staircase that we're forming, but we're connecting it all together into a line. So the cost increases $3 for every CD created. So what we just did is we just graphed our ratio tables that we did yesterday. That's what we just graphed. And it forms a line. As a side note, this graph is called a linear graph. Why do you think it's called a linear graph? Who can tell me why they think it's called a linear graph? Who can tell me why they think it's a linear graph? Let's see. Lucas, go ahead.
I think it's called a linear graph because you can, if you take away the A and the R in the word, it spells line.
Yes.
So you have to do something with it.
Exactly. Lucas is spot on. It has the word line in it. So it contains that word line. Now, let's look here. I want to create more of these identical ratios. So these identical pairings, okay? So by looking at this, here I've got 1, 4, okay? So my thing is 1, 4, and my pair is 1, 4. So based on this next one, 2. What number do I think is going to go there, Hovsep? What number do I think is going to go with the 2?
It's going to be 2,8.
2,8, and that's exactly what we get. What about Sophia Goldstein? What are you getting for the 3?
3. You would get 4,16.
Ooh, so we're getting close. We would get 4,12. She was just doubling it. I get that. That was just what happens. But we are increasing by the same amount. So based on that, let me think then, Delaney, what you're going to get for number 4? Tatiana.
Okay.
Mom, is the Wi-Fi out?
Wait. So, it's going to be 4, 16.
Yes. So each time, what we've gone is we've gone up by 4. Between each of them, we've gone up by 4. And between here, we've gone up by 1. So this is an equivalent ratio in the sense that they constantly are following each other. On this other side, we're still going up by just 1, because we always have to make sure that whatever we're doing, we're going up by our matching 1. But we're going up by 6. So we know our 6 is 6, 12, 18, 24. So our commas are going to be the exact same thing, our ordered pairs. It's literally just going to be 2, 12, whatever it is. So we see all of that. So now I wanted to graph it. If I was going to graph my ordered pairs. So the first thing, if I was going to graph, I'm going to graph Renee. So here at 1, I'm at 4 here, and I'm going up, and I kind of form this line. So there I go. There's me, there's Renee. And now I'm going to graph Gina. Oh. So look at what happened here. We didn't do anything wrong, by the way. Here's Gina's line, as opposed to here. which is Renee's line. So, what do we see? There's a difference here, right? Who has more photos in their scrapbook? Who has more photos in their scrapbook then? Jamal?
Gina.
Yeah, Gina. Hers are increasing at a higher rate. Hers are increasing, going up by 6 every time it goes over by 1. Here's what we see. The steeper the line, the bigger the ratio. So steep. Which line is more steep? The first line or the second line? Holding up our fingers. Which line is more steep? First line or the second line? What do you think? Yeah, the second line. So steep means it's going to be increasing and or even decreasing at a faster pace. So that's when it's at a faster pace. And that explains because it makes it a bigger ratio. So now I want you guys to go to page 48. So now we can work together here. I want you to go to page 48. And this is problem B. Okay? So what here is what we see. The table shows Gloria's earnings for 1, 2, and 3 hours. The table also lists this information as ordered pairs. So it wants you to graph the ordered pairs and describe the pattern. By describing the pattern, I want you to tell me it's going to be blank to the right or left and blank up or down. So it's going to be a certain number that's going to go here. And you're going to have to tell me how much each goes to the right and how much each goes up or down. So we're going to think about that. So I'm going to graph this 2 different ways, and I hope that you're actually going to, I can't even do it because I didn't leave enough room. So what I'm going to do is when I go over on my x-axis, mine is 1, 5. So I'm going to go 1, 5. I'm going to go 2, 10. And I'm going to go 3, 15. Does that look like what you guys got? Yeah, excellent. So you guys are all getting it correct. So we see things like that. And hey, look, I can even make mine go through that origin, that 0, 0, and it's still a straight line. So that's something that most of the time will happen. Let's describe this graph. How many units is it to the right or left? So what is it? And it's units. Tell me, how many units to the right and or left? Which one is it? So I want to see then, I'm going to pick on Noah. What is it and what direction?
It is going 1 square to the right.
Excellent. So it's going 1 square, 1 unit to the right. Okay, excellent. Let's see. How about Ben V? What about the up and down? How many units is it going, and is it going up or down? What do you think? It goes up, and it's going up by 5s. So it's going up by 5s. Hey, look, it's exactly what we see here. 1, 5. We just follow that trend. It's going to the side, to the right 1, and then up 5. Now, I know that we're saying like, oh, but it's only 2.5. I know, but if you look at the side, always make sure you look at the units on the side. So each of my units, each box up this direction was 2 and this direction's 1. Yes, that is allowed as long as your units don't skip about. So if I made this 1, 2, 3, 6, 12, like that's when we have a problem. They have to be comparable units. They have to go in order. So exactly, this is what it should look like. Here's what I also want in your books. This is what we were just talking about. Units to the right, units to the up, to the down, to the left. We're going to deal with this more later, but I want this prefaced in your book. So one of the things we were just working on was rise over run, or y over x. This is also known by the letter M. Don't worry, we'll get into it. You don't need to know this now. And it's called the slope. Like I said, we're going to get into that during chapter 5. But it's important to have this written down. I wanted to preface what we're going to be doing later. 2 friends are each saving money in their bank accounts. Marcus saves $10 each week, while David saves $15 each week. So I want to know, here's Marcus's thing. There's Marcus. What number is going to go in that circled spot, Vahe? What number is going to go in that circled spot?
10.
10. And he knows this because Marcus saves $10 each week. If it's been 1 week, he has $10. And our ordered pair is 1, 10. Literally, the ordered pair is the easiest thing that you guys can do. It's just writing those numbers in X, Y, and it tells you. What about on the other side, David? What number is going to go there, Michaela?
So 1, 15.
Perfect. She says 15, 1, 15. Excellent, you guys. All you need to do is fill out the rest of the charts with the multiples. So to get from 1 to 2, it's times 2. So I'm going to do the exact same thing, times 2. 10 times 2 is 20. So my point is 2, 20. 15 times 2. If I'm doing this one, we get 30. So our point is 2, 30. So we see this going back and forth.
No, Mom.
So as we see this, our next numbers are 30 and 40. So 3, 30 and 4, 40. On this other side, we get 45 and 60. Again, all we're doing is we're doing our multiples. So practice your multiplication if this is a bit hard on you. So congratulations. We just did problem number 1. This is what our graph would look like. All we do is we fill it out with multiples. They are equivalent ratios. They are worth the exact same amount. If I divide them, if I simplified them, I would get this exact same amount every time. It'd be the same. So now I want to graph it. So I'm going to graph Marcus's in red. After 1 week, he has $10. 2 weeks, $20. 3 weeks, $30. 4 weeks, $40. Awesome. What about then David? I'm going to graph David in blue. David, after 1 week, he had $15. After 2 weeks, he had $30. After 3 weeks, he had $45. And after 4 weeks, he had $60. Let's look at these lines that I made. Who is steeper? Which one is steeper? Let's see. Sophia, Kay, which one's steeper? Yes, so this top one right here is steeper. David's line is steeper because David is saving more money. So how do the ratios compare? We see that again, David has a higher ratio. He has a higher ratio. He's saving more money. How is it shown on the graph? It's shown on the graph because of the steepness. It's shown on the graph because of the steepness. Let's say they both wanted to save something and they both wanted to save to $200. Looking at this graph, even without knowing how much exactly they earn, just if I looked at this picture, right here, and I'm going to make it so it's a little bit clearer for us. Who do you think is going to get to $200 first? The green or the yellow? Just by looking at this, who do you think is going to get to $200 first? Let's see, Marley. Green. Exactly. It is surpassed it by a lot. Look, here's when they had the same amount of money, but one had it at week 2 and one had it at week 3. So that's how we can look at a graph and determine which has a higher ratio. This is how we can look at a higher ratio and determine which graph is going to be steeper. So we see all of this. Now, as we know, who has more money? As we said before, David has more money than Marcus. So David's line is more steep than Marcus's. David's line is more steep than Marcus's. So homework is page 51, just numbers 1 through 4. Just numbers 1 through 4.